Hello everyone, this is Dr. London, and today we're going to go over the test 2 review. So again, test is mostly on polynomials and the beginning of exponential functions. So let's go over a couple of questions that should be representative of what you'll see on the test. So let's complete the table and graph f of x equals 3x squared minus 5. So the table is just the values from -2 to 2 increasing by 1. So -2, -1, 0, 1, and 2. So basically we square this number, multiply it by 3, and then subtract 5. So we would have 3 times 4, I can write down the steps. We're just replacing x with this one. 3 times 4 minus 5, so that's going to give us 7. Then we would have 3 times -1 squared minus 5. That would give us minus 2. Then we would have 3 times 0 squared minus 5. That would give us -5. 3 times 1 squared minus 5 would again give us -2. And 3 times 2 squared minus 5 is going to give us 7 again. So then we can go ahead and graph that over here. And we see this is the parabolic shape that we recognize with all quadratic functions. So our furthest left and right points are going to be all the way up here at 7. So at -2 and at 2 we're at 7. At -1 and 1 we're at -2. And we're all the way down at -5 at our minimum value. So our parabola is the kind of U shape that passes through these 5 points. So basically plugging in points and being able to graph them, pretty straightforward. For number 2, let's say we want to find the net change and average rate of change for f of x equals 6 minus x squared on x equals 1 to x equals 3. So remember, the average rate of change is essentially similar to the slope formula. We just have to find the y values first. So let's find both of those y values. So f of 3 is going to be 6 minus 3 squared, which is -3, and f of 1 is going to be 6 minus 1 squared, which is 5. So our net change is just the difference between those two. So that's going to be -3 minus 5. So that comes out to -8. And then our average rate of change is the ratio of the change in y over the change in x. So it's going to be -3 minus 5 divided by 3 minus 1. So that will give us an average rate of change of -8/2, which comes out to -4. So those are both the net change and average rate of change for that function. Number 3, we'll look at doing some composition of functions. So let's suppose f of x is 5x plus 1, and g of x is 3 minus x squared. So let's say find each composition. So let's say we do f of g of -2. So remember, that really just means we're plugging negative 2 into the g formula, and then plugging that result into f. So g of negative 2, that would look like 3 minus negative 2 quantity squared. So that is going to be f of, well, that's 3 minus 4, so f of negative 1. And the way you do f is you do 5 and replace x with negative 1 and then add 1. So that's going to give us negative 4 as our answer here for part A. And for B, we'll just do the composition in the reverse order. So let's do g of f of negative 2. So that means this time we plug negative 2 in for f, and then plug that result in for g. So remember, what does f do? Well, it's going to be 5 times negative 2 plus 1. So now we're doing g of minus 9. And g was 3 minus x squared, so now this is going to be 3 minus negative 9 quantity squared. So that's going to be 3 minus 81, which will give us a result of negative 78 here. So notice again that the compositions are probably not going to be the same when doing them in reverse order. So that's okay. For number 4, let's go ahead and find the vertex and intercepts of a quadratic function. So for find the vertex and all intercepts of f of x equals 2x squared minus 8x plus 16. So the vertex formula, remember, it tells us that the x-coordinate of the vertex will occur at negative b over 2a. So that is going to be the opposite of negative 8 over 2 times 2. So that's positive 8 over 4, which results in an x-coordinate of 2. The y-coordinate, we just plug into the function. So we would have, say, f of 2, which is 2 times 2 squared minus 8 times 2 plus 16. So what do we have here? We have 8 minus 16 plus 16. So we have our vertex of just 8. So the vertex here is 2, 8. So that's one of the things we need to find. Now we need to find all x-intercepts and y-intercepts. So so this is, I guess I'll box this in because this is one of the things we're looking for. So the y-intercept is also quite easy. The y-intercept, we just plug 0 in for x. So what does that look like? That's f of 0. So that's 2 times 0 squared minus 8 times 0 plus 16. So that gives a result of 16. So our y-intercept here is 0, 16. So that's the y-intercept. So the last intercepts we can look for are our x-intercepts. And the x-intercepts, we would set f of x equal to 0 and solve. So for the x-intercepts, there could be, remember the possibilities, there could be 1, none, or 2 for a quadratic function. So for the x-intercepts, we have 0 equals 2 times x squared minus 8x plus 16. To make solving this a little bit easier, you can divide everything by 2. So if you divide both sides by 2, you end up with x squared minus 4x plus 8. So then this factors into x minus 2 times x minus 2. Oh, sorry. That's incorrect. This would not factor like that because what you would essentially need is you would need two numbers that multiply to 8 and add up to negative 4. So there aren't any of those. So what we want to do here is just use the quadratic formula. So we would have x equals 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 8, with everybody being divided by 2. So here x would be 4 plus or minus the square root of, well, we would have 16 minus 32, negative 16 over 2. So this is going to be an imaginary number because the square root of negative 16 is imaginary. So we can, for this purposes, say no x-intercepts. Or you could put maybe DNE for does not exist. So that is it for that question. We have the vertex, we have one y-intercept, and we have 0 x-intercepts. Okay, number 5, let's say describe the end behavior of each polynomial. And remember, this can be completely determined by just looking at the leading term of the polynomial. Nothing else really matters. So let's say we have f of x equals minus 3x to the 5th plus 11x squared minus 9. So the leading term is minus 3x to the 5th. So minus 3 is the number in front. So we would say it's negative. And the power is 5, so that's odd. So you can go back to the notes from this section, graphing polynomials, and we broke this down into 4 cases, so I'm not going to rehash that here, but this would mean that the left side rises and the right side falls. Another way to say that is as x goes to negative infinity, which means as you're moving to the right, y would go to positive infinity, hence rising. So to the left rises, and what happens as we go to the right? Well, to the right is in the positive infinity direction. What is y doing? It's going down, so y is going to negative infinity. Sorry, I messed that up there. But that is the equivalent way of saying, using the infinity notation, what we just said in words. Let's do another one of those. Let's say we have g of x is 7x to the 6th plus 11x cubed plus 1. Again, we're just looking at the 7x to the 6th, so this is positive and even, which means both sides rise. Or equivalently, as x goes to infinity, y goes to infinity, and as x goes to negative infinity to the left, y also goes to positive infinity. Positive infinity would be the up direction for y. So that's the end behavior for both of those polynomials. Let's take it a bit farther in this next example, and let's go ahead and just try and graph. So let's say graph f of x equals x to the 4th plus 2x cubed. So we need to talk about the end behavior first. So that's just like we were doing in the previous example. We want to look to the x to the 4th. So that's positive and even still. So we know both sides rise. And then we want to look at the intermediate behavior, which is going to require us to factor that polynomial. We want to know what's happening at each of the x-intercepts. So our f of x can be factored. We can take out an x to the 3rd power, and that would leave us with an x plus 2. So remember, we have our 0, the multiplicity, and the behavior. We can make this little chart, and that'll tell us what's happening at each of these x-intercepts. So what are the two x-intercepts? Well, you have 0 that comes from the x to the third factor, and then your second 0 is -2, which comes from the x plus 2 factor. So the x is raised to the third power, so that has multiplicity 3. The x plus 2 is just raised to the first. And if the multiplicity is odd, then it's going to cross at each of those. If it were even, it would bounce off the x-axis there. But for both of these, it crosses. So essentially, we know our graph basically has to hit the x-axis at 0 and also at -2. And it needs to cross the x-axis at both of those places. So essentially what's going to happen is you're going to cross here, and then the third one you're also going to cross, and it'll go through a little bit flatter, but roughly look like that. So this is going to be a picture of your graph. And that's it for sketching the graph. So the next couple are going to be just synthetic division. So 7, divide, let's say, I don't know, let's say f of x equals minus x cubed minus 2x plus 5 by x plus 1. So for the synthetic division, we put the root in the top left corner, so that's -1. And then we want to put the other numbers on top, so we would have a -1. There's no x squared term, so I have to put a 0 placeholder there. I have a -2, and then I have a 5. And remember how the synthetic division works. We drop down the first number, the -1, multiply it by the number in the corner, and write the result below the next number on top of the line. So that would be a 1 here. Add 0 plus 1 gives us the 1. Then multiply by -1 again. So then we add -2 plus -1 is -3. Multiply with the number in the corner. That gives +3. So then when you add, you end up with a remainder of 8. So essentially this is telling us that minus x cubed minus 2x plus 5 divided by x plus 1 gives a result of minus x squared plus x minus 3 with your remainder of 8 over that divisor of x plus 1. 8, let's go ahead and look at divide, let's say p of x equals x to the 4th plus 3x cubed minus 18x by q of x equals x minus 4. So again, setup is similar. We have our 4 that we're going to put in the corner because 4 minus 4 is 0. And then we have a 1, a 3. There's no x squared term, so we get a 0, minus 18. And then we have another 0 for the constant term. There's no constant term either in p of x. Then we go through the synthetic division. So bring down the 1, multiply it with 4, or add 3 plus 4 is 7. Then we take 7, multiply it by 4, we get 28. 0 plus 28 is 28. And then you want to multiply that by 4. That should give 112. And then do 112 minus 18. That should give you 94. And then do 94 times 4, which should be 386, I think. Let me check that with the calculator here. Make sure I did those right. I just did them mentally pretty quick, but doesn't hurt to check. 376, not 386. So yeah, my mistake there. 376. That's why we checked. And again, we could see this as p of x, that polynomial, divided by q of x is equal to what? It's equal to, let's see, remainder constant 1, 2, 3. So we start with x cubed plus 7x squared plus 28x plus 94, and then plus our remainder 376, which is being divided by q of x, or x minus 4. So that's it for that division problem. Okay, so let's look at a couple of problems that involve the exponential formulas. So 9, let's say a bacteria colony starts with 150 bacteria and doubles every hour. What is the population after 3.5 hours? So we need to come up with our exponential formula, and we know exponential functions basically look like f of x is a times b to the x, and a represents your typical starting amount, which here is 150, and b represents your exponential base, which is what it's being multiplied by each unit time step. So it's doubling, so that makes this pretty easy. We know here f of x, or maybe for this problem we should use t because it's time. So let's just call it t instead. So f of t, our initial amount 150, is being multiplied by 2 to the t power. So this question is essentially just asking us to plug in 3.5. So we get 150 times 2 to the 3.5. So let's plug that into the calculator. So we get 1,697.06. So we could say there are about 1,697 bacteria after 3.5 hours. And that would be it. And then for the last one, we'll look at a compound interest formula. If you invest $8,000 in an account, earning 2.3%, compounded quarterly, what is the value after 5 years? So let's remember our formula that we're going to use here. Our future value is equal to the present value times the quantity 1 plus the rate as a decimal over n to the nt. So we are investing $8,000. That is replacing P. And then R is 2.3%. We need to change that to a decimal, so that's 0.023. We're being compounded quarterly, which is 4 times per year. So, and that is being invested for 5 years. So this is what we need to plug into our calculator, and that'll just give us the answer directly. So we can punch that in. Be sure to use parentheses, especially if you do not see an exponent notation on your math type. You'll want to put the exponent in parentheses as well if it's just a caret. So just double checking mine, and I am getting $8,972.03. Does everything look reasonable? Yep. So that's it for compound interest. So essentially, that's a good review of the types of problems that'll be on our second test. If you have any questions, please feel free to email me. This is Dr. Lennon signing off.